Hello dear students, so now today we would move ahead in this first chapter of class 12 chemistry, that is solid state. So here today we are going to talk about the types of crystalline solids. Okay, so there are four types of crystalline solids. So first one is the ionic solids. Ionic solids. So what are ionic solids? Means the solids which are made up of ions, means the constituent particles would be ions here. Okay, so in case of the ionic solids, what are the constituent particles? Means the smallest particle through which these ionic solids are made up of. So these smallest particle, the constituent particles, would be the ions. Okay, and what would be the force of attraction between the ions? This is how the ions are bind together. So there would be the force of attraction between the ions. So this force of attraction due to the ionic bond. Okay, are you getting it? Yes. So the constituent particles are ions here, and they are holded together, or they are bind together by the ionic bonds. Are you getting this? And one more thing that you have to remember, these solids are hard also and do not conduct electricity in their solid state. When ionic solids are in their solid state, so they do not conduct electricity at all. But in case of the molten state, why they are not conducting electricity in solid state? Because there are not free ions. The ions are not free to move, so they cannot conduct the electricity. But in case of the molten state, when these solids are in molten state, the ions are free to move, then they can conduct electricity. So ionic solids can conduct electricity in their molten state, but in solid state they do not conduct electricity at all. Okay, so let me write about the ionic solids. So this is all about the ionic solids. This is the first category of the crystalline solid. Now the second category of the crystalline solids is the molecular solids. Okay, so what are the molecular solids? Means here the constituent particles would be what? The molecular solids are made up of the molecules. Are you getting? Yes, so the constituent particles are molecules here. Okay, like different iodine molecules are joining together by weak van der Waals forces, like this. So they are joining together to make the iodine molecule. Are you getting this? Molecular solid means, okay, simply the molecules of water are joining together again by the weak van der Waals force. These are going to join each other by the weak van der Waals forces. So hence they are also the example of what? The example of molecular solids. So this is this kind of structure they are making. Are you getting this? So these are the examples of molecular solids. Means here the molecules, means the constituent particles are molecules here, because they are made up of the molecules. That is why they are molecular solids. Okay, and the forces of attraction between the molecules would be the weak van der Waals forces, or sometimes the hydrogen bond also. Okay, so due to the hydrogen bond and the van der Waals forces, so there are some forces of attraction, but these forces of attraction are very weak here. So that is why these solids are not too much hard. Why not hard? Because the forces of attraction between the molecules are not strong, like in case of the ionic solids. The forces of attraction were very strong, ionic bond. Okay, so that is why they were hard. But these are not hard. Why? The forces of attraction between the molecules are not very strong there. Okay, so let me write about the molecular solids also. And let me tell you one thing, we can divide these molecular solids further into three parts. Okay, some are non-polar molecular solids, some are polar molecular solid, and some are hydrogen bonded molecular solid. Like here we have the hydrogen bonded molecular solid. So here this is the example of hydrogen bonded molecular solid. Some are the non-polar molecular solids, like iodine, it's a non-polar. Some are polar molecular solids, or like in case of the HCl. Here as positive and say these are the polar molecular solids. Okay, these are the polar molecular solids. So HCl is the example of polar molecular solid. So we can divide the molecular solids into three categories. Okay, so first you write about these ionic solids. Now let me write about the molecular solids here. So this is all about the molecular solids. So third one category of the crystalline solids is the covalent solids. Covalent solids. So what are the covalent solids? Like in case of the molecular solids, the constituent particles are molecules, and the molecules are held together by the force by the hydrogen bond and the van der Waals force, and these forces are very weak. That is why they are not too much hard. Okay, and again we can divide these molecular solids into three other categories: non-polar molecular solid like iodine, polar molecular solids like HCl, then hydrogen bonded molecular solids like H2O. Okay. Then we have the third category of the crystalline solid, that is the covalent solids. So covalent solids means these are also known as the network solids. We also call them as the network solid, because the solids which are here are going to make the network like we have done in the example of this what can I say, this diamond. Are you getting this? Diamond. So diamond is the best example here of the covalent solids. Okay. So here's the example suggests these covalent solids are going to be very hard, very hard. Okay. You are knowing diamond is the hardest one. Okay. So here what are the constituent particles are? If you see, all the carbon atoms are joined together and they are making the network like structure again. Okay. So the constituent particles are here the atoms. Okay. So in case of the covalent solids, the constituent particles are atoms. Okay. And the forces of attraction between the constituent particles are the covalent bond. Okay. So and the covalent bond, you must be knowing covalent bonds are very hard. So it is very hard to break the covalent bond there. Okay. So that is why these solids are very hard. Okay. And brittle also. Are you getting this? Yes. So the constituent particles are atoms here and they are held together by the covalent bond. So there are the covalent bonds between them. That is why they are very hard, because covalent bonds are very hard. Now one more thing, let me tell you. These are very poor conductor of electricity. They do not conduct electricity at all. Okay. They do not, like we have the example here, this diamond, then silicon carbide also, one more example is there. Okay. But one exception is here in case of the covalent solids which conduct electricity, that is graphite, and which is not too much hard. That you must be knowing, graphite. Okay. So graphite is the exception here which conduct electricity and not too much hard also. And the rest of the covalent solids are very hard. Are you getting this? So let me write about the covalent solids also. Before this you note it down. So this is all about the covalent solids here, and also known as the network solids. Okay. So here the atoms are the constituent particles, and the constituent particles are held together by the covalent bonds, and hence because the covalent bonds are there, so that is why these solids are very hard and brittle also in nature, and they do not conduct electricity. And one more thing, they have very high melting point. Example, diamond and silicon carbide. And one exception is here, that is graphite, which conduct electricity also and which is not too much hardware. Okay. So that was the third category of the covalent solids. Now let's move towards the next. So here we have the fourth category of the metallic solids. So at first the constituent particles. So electrons and kernels are the constituent particles. Electrons, you might be knowing, kernels means the atom without the valency cell. Atom without the valency cell is known as the kernels. That you should know. Okay. So electrons and the kernels are the constituent particles here. Okay. And the constituent particles are held together by the metallic bond, that you must be knowing. Okay. And what are the metals? If I just define the metals, so metals are just the orderly collection of the positive ions. So all the positive ions are there, because all atoms, metals are, these are all are made of the positive ions surrounded by the sea of electrons surrounded by the and held together by the sea of electrons are there. Means many positive ions are there. So all positive, that you might be knowing now. In a metal atom, you are having a nucleus which is the positive ion, positively charged nucleus, and it is surrounded by the electrons. So similarly, all the atoms are there. So we can say that metals are the collection of the orderly positive ions surrounded by the sea of electrons. Sea of electrons means many electrons are there, and these free electrons are responsible for the conduction of high electricity and thermal conductivity also. Are you getting this or not? So these free electrons which are there surrounding the positive ions. Okay. So these free electrons are responsible for the high electrical and thermal conductivity of the metals. This is the reason there, that metals are good conductor of heat and electricity. Getting it or not? So that is all for today, where we have discussed about the types of crystalline solids. Okay. Then in the next lecture we would move ahead and we would discuss further topics. Till then, stay tuned and keep watching. Thank you. Have a good day.